The learning outcomes of this project are as follows. This is a quick overview of the hardware setup. We have the spill-proof container, the water reservoir, the black box, the water pump with the hose coming out. Here is the battery, the wire from the battery going to the pump, and then this is connected to the MOSFET, which is in the Grove board. We have the temperature sensor that I've added and the soil sensor that is inside my dying basil plant. This operation portion of the video is sped up to 1.65 times with my regular speed audio recorded separately on top. We see here that currently the state is in the waiting state, the mandatory 55-second pause between watering bursts. Once this completes, it will once again check for the moisture percent, and if it is either equal to or below 30%, it will water the soil. And if it is exceeding or equal to 70%, it means that the soil is wet and does not require to be watered. Due to how dry my plant is, in the loop it waters the plant 5 times. The system is designed to water for up to 7 days or until 2 liters of water is used. There are 6 states in the system, state 1 being that the soil is dry or the ambient temperature exceeds 30 degrees Celsius. State 2 is an emergency stop, errors triggered. State 3 is a mandatory timeout between watering bursts. State 4 is that the soil is wet. State 5 is monitoring. The moisture percent is between 31 to 69%. State 6 is exiting. The loop completes and a buzzer sounds. The loop itself is comprised of a while loop with if, else statements and while loops nested within it. The loop calls various functions that were created to execute the system, such as calibrating both the temperature and soil sensors, converting output voltages to either degrees Celsius or moisture percent in a live graph that you see being generated as the system runs in red in the corner. The peaks seen on the live plot represent the watering bursts, and the moisture tapers off as the water soaks through the soil. Emergency stop was programmed into the system as a manual override programmed into the existing button on the Arduino board. Once pressed, an error is triggered and the loop ends immediately, and a message appears for the user as seen on the screen shortly.